Most APIs are simple and easy to understand. If you take something like REST API, it's self-explanatory and just uses normal HTTP requests. GraphQL is unfortunately not like that. It's hard to understand, difficult to enumerate, and just a general pain in the arse to deal with whenever you see it. But if there's something hard, that means it's going to scare away a lot of other bug bounty hunters, which means that there's more bounty to be had in it. Just look at something like iOS hacking, which is very underestimated by bug bounty hunters. That's why in this video, I want to give you a detailed breakdown of how you should approach a GraphQL endpoint. And stay tuned to the end of the video to see a live example of me actually doing that on an application. I'll start off with a quick explanation of what websites actually use GraphQL for. So if you look at this diagram, you can see that the server is fetching data from a database using SQL. So this is the normal procedure for how a server will fetch data directly from a database. It'll send an SQL query, which will then be processed by the database, and the database will send back some data that the server requested. And this can also be a changing query, so a query that actually affects data in the database, or it can just be a query that actually returns data. Either way, the database will return some kind of response. Why is this bad to use in an API context? Well, if you let a user directly send SQL, it's not very easy to limit what they can actually do. It's hard to implement things like authentication authorization that prevents a user from modifying another user's data. That's why whenever you have a website, it's very bad practice to expose a website directly to a database unless it's for a specific reason and it's properly moderated. The much easier way to do it is through something like a REST API, which just sits between the server and the database and converts the user's basically instructions like functions into SQL and then returns data in a properly handled way. So the database will return data in the SQL format, in tables and stuff like that. But we probably don't want to return that to the user. We want to return something like JSON to them when we're sending requests across the network. So that's what the REST API really does. It just sits in between the server and database, kind of acting like it's a middleman and handling stuff like authentication, authorization, and also turning the data from something that's more readable to a server to something that's actually better for a API, which is normally JSON. Could also be something like XML. That's actually exactly what GraphQL is for. It's just that intermediary layer. And the advantage of using GraphQL over something like REST is that we don't have to code a lot of this ourselves. There's a lot of REST frameworks out there, of course, but GraphQL also has a couple of different advantages which I'll touch on in a minute. We can see that it kind of works the same way as the REST API I just described, where the GraphQL server will send a GraphQL query in GraphQL language to the GraphQL middleman here. And all the GraphQL will do is actually just convert that into SQL and then just send it onto the database. So it just sits as that middleman layer. And the database, as normal, will just send the data to the GraphQL query. And then it will actually return that data in the format that the server wants it to. So in the GraphQL format. There's also one other advantage of GraphQL, which is performance. Because in normal REST APIs, we kind of don't have a choice. We have to accept all the data from an endpoint. For example, if you have a user's endpoint /users, if I want to have the details of a specific user, let's say ID1, I will go to API endpoint /API/user/1, right? When I go there though, the server normally will return the whole data related to that user, like username, email, profile picture, and the whole shebang, right? We might not want all that, and because the server returns all of this, then it's going to have to fetch all that from the database, it's going to have to connect to it, and it's going to have to download all the data. So that's not that great on performance if we want to minimize it. With GraphQL, we can choose exactly what data we want from the database. So we can choose if we want just the username, want just the email, or a profile picture, or all of them. So that's one thing. GraphQL is better for performance in that way than some of the other REST APIs, unless the REST API has specific systems that allow us to just only choose a few of them. which not a lot of them do, to be honest. So that's one advantage of GraphQL. And yeah. So this is just a typical GraphQL query, and this is what graph query language looks like. So you have SQL for accessing websites directly, for accessing the database directly, but this is graph query language in order to access that middleman you see here, so sending it from the server to GraphQL. And this is the syntax that it expects. First of all, we define what operation we actually want this query to be. In this case, we just want it to be a query, which means we just want it to return data. There's a few operations. There's a query, which just returns data. There's a mutation, which changes data on the database. And there's a few other ones, like this is subscription, which creates a WebSocket connection. We'll focus less on that. We'll focus mostly on the query and the mutation in this episode. So we've defined it that it's a query, so we want to only fetch data. We give our query a name. This doesn't actually matter. This can be called anything. And then in these brackets here, we basically kind of define the variables for our query. And this will normally be passed in from a JSON endpoint. So in the context of this, there'll be like a GraphQL endpoint on a website, and we'll pass the data in through JSON, and then we'll include the variables in that JSON. So here we have the query name. So this is defined in the server in the schema of the GraphQL database. And then we can pass in parameters. So we can either like request all the cities and not pass in these parameters at all, or we can choose a specific city. Some endpoints require you to have these parameters and some don't. You can see we can pass in a variable as a parameter here. And then we can request here the data that we want from this GraphQL query. So what we want to know about these cities. In this case, we want to know the population and weather. And weather has its own data points that we need to define, and then we can also go deeper and deeper from this. So you can see that instead of basically getting every information about the city, we just chose to have the population and weather data. Maybe there was like building names, like street names, but we didn't want that, so we don't want this database to fetch that and waste energy basically downloading that information. That's good. We saved a bit of performance there. And this is a GraphQL mutation. So you can see instead of query, it says mutation here. And it follows a very similar format to the query syntax, where this thing here is just the query name. Doesn't actually matter, doesn't affect anything. And these here are our inputs. So these inputs aren't just plain strings, they're actually they're different objects. So these are defined in the schema, and we might need to pass in more parameters in here. The exclamation mark just means it's mandatory, so we actually need to pass in this parameter. If we don't pass it in, the query will fail. And then here we're just creating a review. So this is going to be the mutation name defined in the schema. So this was created by the developers to allow us to create reviews. And then we have the two parameters, so episode and then the review name or something like that, right? So these parameters, you pretty much have to pass in parameters whenever you're creating an object, because then that data will be passed in to the object in the database. Yeah, so that's basically a mutation here. Mutations can either modify data or create new data. It doesn't really matter in GraphQL. And same as the query syntax, we actually need to pass in some kind of data points that we want from this operation. Whenever we create this mutation, it's still going to return data to us. And in this case, it's going to be data about either the newly created object or the modified object. And we can choose what data we want. This actually also is better for performance, because in a lot of REST endpoints, we might not get this back. It might just say like item created or something like that. But in GraphQL, we won't have to send like a second query. We could just request the exact data we want. That's also good. And yeah, that's basically the syntax for GraphQL. It's not that hard, and I'm going to move into a live example now, which is going to show you how this looks in a JSON endpoint, and I think it's going to make a lot more sense there. Just to recap, GraphQL is like a REST endpoint API, which just sits in between the server and the database, and basically allows the user, like a publicly accessible user, to communicate with the database without creating security risks and also improving performance. That's the purpose of GraphQL. So this is a application that I'm going to use as my live example today, and it's called the Damn Vulnerable GraphQL application. You can find this online. It's just a GitHub repository. I'm going to use it so I don't have to make a whole GraphQL application because it's a bit of a pain in the arse. So thank you to developers for this. And we're going to basically try and find some vulnerabilities in GraphQL, and I'm going to show you how I'm going to approach a GraphQL application like this. So the first thing we want to do is basically see if this is a GraphQL application at all. We want to see kind of perform some actions. So to do that, I'm just going to go into create a paste, and I'm going to say, call it like test or something, message 123. And before submitting it though, I'm going to hop in here into Kaido. I'm going to make sure that Kaido is on. It is. There you go. And then I'm going to intercept this request. Hopefully when I click submit, it's going to intercept a GraphQL request. Let's click this button, submit. It intercepted something, it seems. And yeah, it is a GraphQL request. Sign into the repeater so you can see it. And there it is. This is our GraphQL query. And in this case, it looks like it's a mutation, which makes sense because we're creating a new object. And the key thing about GraphQL, which actually distinguishes it from REST, is that GraphQL will sit on one endpoint, while REST has like thousands of endpoints, right? So instead of having some like separated API/users endpoint, we're just going to have one GraphQL endpoint where we send all our queries to at the same time. You can see the first kind of object here in our JSON object is called query. And then after that, we have our variables that are going to slot right in here where I showed it before after the query name. Sometimes it looks a bit different, sometimes like beforehand, sometimes the query is after. Most of the time the GraphQL endpoint will look like this though. Now there are some older implementations that actually use the query parameter here. So that use something like this, and then we'll have the request like there, so up here. That's very old though, and it's also not that safe. So most endpoints use this instead. Let's just see what happens when we post this. We get our object back, which is exactly what we requested in here, and all the data that we wanted, so ID, content, title, and burn, is in here. And this is the same query as we basically saw before, except that this time it's formatted in JSON, which means instead of having like actual spaces, there's line breaks, and that makes it look a bit uglier, but it's okay, we can still read it and it still means the exact same thing. If we say removed ID, like we don't want the ID anymore. We cut it out, and there it goes. It's not there anymore because we don't want it. So we can pick and choose what things we want and what things we don't want, which is advantageous if we're implementing this as an API. What kind of vulnerabilities can we find in GraphQL? And the answer is really the exact same vulnerabilities as in any REST API, which is the standard web vulnerabilities, so XXS, cross-site scripting, server-side request forgery, that kind of thing. We can test for all those like injections, and then we can test for things like broken access control. So the ID parameters here, we can try and change the ID parameter to access another user's data instead of our own. We can try and create data for another user. We can try and delete another user's data. We can do all that stuff with REST API, test for all the broken access control, same injections. And there are some GraphQL specific vulnerabilities. Most of them are denial of service vulnerabilities. So in GraphQL, you can do things like batch requests, which means send multiple queries at the same time in the same request, and that can get around some kind of rate limiting. Some programs will accept these vulnerabilities, most will not. That's why I advise you to look for more standard web vulnerabilities when attacking GraphQL, because these denial of service, unless you know what you're doing and you're hunting on a program that actually cares about these denial of service vulnerabilities, I would advise you to stick to the standard web security vulnerabilities. Looking at this endpoint, the only thing I can really think to test for is something like cross-site scripting, to see if the website is placing our user input unsanitized onto the web page. So we'll do that. we'll see if I put some kind of HTML tag here, if it'll render. I'll also put it in the content page, like so. And I'm going just to see if something renders in here. So we got our request back. It seems like the tags weren't filtered out, so that's already a plus. They'll probably make it onto the page at least. I think I made this a private repository. I made it public. So if you go to public, okay, yeah, it seems like we have a bit of cross-site scripting happening here. So if we go here and we try and find, okay, there it is. We try and find it here. It seems like the tags have been injected. That's good. We found one vulnerability there. We could try and test something like JavaScript now as well. Today, some like script alert or something like that. Classic. We'll see if we can render JavaScript, and if we can probably perform something like cross-site scripting. That tag there as well. So we'll send that in. We'll just refresh our page. Oh, it seems like it did get filtered. Interesting. Maybe not. Okay, it didn't get filtered, but the alert box didn't pop. We could probably get it to pop, but you get the point. We found an injection point, just like a standard web security vulnerability in GraphQL. And the fact that this GraphQL doesn't change anything, if this was a REST API endpoint, the vulnerability would still be there. So we can basically test for these kind of vulnerabilities on any API framework, regardless if it's GraphQL, REST, gRPC, or whatever. Okay, that's one of the security vulnerabilities we found. And this was a mutation. Let's maybe look at a query and see where we can find vulnerabilities there. Going into these public pages, we can actually refresh this and see where the website is actually getting this information from. Let's go somewhere like here. Okay, it's getting something here. It's getting a lot of static files. Maybe I should filter some of these out because they're annoying. Go here, and we have a post sent to GraphQL. Okay, let's see this then. This is the request that the website is using to fetch the pastes. And we can see here, if we just send it through, it's going to return my private pastes. So that all works as expected. We try and like tinker with this, maybe we'll change it to true, so we'll look at public ones, and it also returns that. And this seems to also be returning my cross-site scripting payload that I sent it previously. And this is basically all the things that I have created and that was there previously. Interesting. Now let's try and filter by an ID parameter. Maybe if we filter by ID, we can gain access, we can change this modifier to a paste that I don't own, and then gain access to another user's private data, which would be quite lucrative pay, I wonder now. So if we send it in, it doesn't seem like that work. I'll feel pastes. So we have pastes. So paste is a plural word for paste. So maybe if we change this to paste, we'll look for just one paste instead of two. Let's send this to, and it seems to have worked. So this is a paste that I own, and the second one is also one that I own. What if we change this to the third one? Let's see. It also returns a paste, but this is not owned by me. This is owned by someone else. So this is a broken access control vulnerability, common in GraphQL queries. This is the kind of the main vulnerability type you'll see when you're hunting on queries and mutations. You'll see more injection type vulnerabilities. Well, for these queries, you'll see more broken access control type vulnerabilities. You can still see here, obviously you can still like change the ID parameter, like delete someone else's query. Sorry, someone else's like data. But here you'll see more broken access control type vulnerabilities because it's hard to do an injection when you're not modifying any data. Pretty much impossible actually. I've showcased two vulnerabilities for you in this GraphQL application, and now I want to show you how to actually enumerate GraphQL endpoints, how to fetch more data about them, and how to basically find hidden endpoints that other people might not be testing for. Prior to that though, I want to say that I have labs in the description right now, and it's very similar to this. It's like a live application that you can find vulnerabilities on, and then you can read my solution to them, which is written in text format, and it'll walk you through how to solve it, and it'll help give you the mindset to attack these endpoints and to spot vulnerability types. These labs are created by me, so these are things that I wish that I had when I was starting out in Bounty. kind of challenging labs that really tell you to think about the problem rather than just know a vulnerability. You have to really consider what context is being applied in. And that's what I really like about the labs that I've made. So check out the link in the description. Now I'll move on. How do you enumerate in GraphQL? Let's look at our endpoint again. These kind of query endpoints here, see this? There's a lot of parameters here. ID, title of content, IP address, user, agent, owner, name. And it's hard to know any of that. These are quite hard to guess parameters. Get paste is an extremely specific word, which you might not get from a word list. So enumerating this seems quite difficult. And GraphQL is harder to enumerate than a lot of other REST APIs, where most of the words are guessable. Most of the API endpoints are contextual, and most of them are honestly like even humanly guessable. With AI, it makes it a lot easier. You can still guess some of these, as you know, in the context. It's just usually harder because GraphQL has a lot more properties that you would need to guess. So you need to guess this, then you need to actually guess all of the properties. With REST API, you would probably just need to guess the name, and then it'll probably fill you in on the rest of it. Right. So how do we enumerate it? I think the best way to do it is to attack the JavaScript first. So to find where the queries are in the JavaScript. JavaScript will tell you a lot. GraphQL is usually not the main API designed for interfacing with other apps for third-party applications. So GraphQL isn't usually the thing that you tell developers to use when they want to implement a website on their platform. It's normally internally used inside the website to handle an API endpoint. That's why in most cases, the GraphQL will be visible in JavaScript and a lot of the parameters will be leaked. As well as this, if things are deprecated, they may still remain in JavaScript, and you might be able to find hidden endpoints there that weren't quite removed from the server, but were kind of deprecated on, like, the functionality doesn't exist anymore on the website, but it's still there on the JavaScript and it's still there on the server. So these are the kind of things we're looking for. Another thing is that the more endpoints we find from JavaScript, we can kind of export into a text file, the better word list we can make with something like ChatGPT, and then we can enumerate the GraphQL endpoint one better. That will allow us to find the hidden parameters, and it also allows us to find the hidden queries and mutations which people might not be looking for. So where do we find GraphQL endpoints in our JavaScript? You can use regex for this, which I really recommend you do, and build some kind of regex in order to find GraphQL queries. You can just ChatGPT it, to be honest. But all GraphQL queries will start with query and space, and that's usually where they're stored in the database. So they're either stored as queries or they're stored as mutations, and here we find a lot of them. So this is not minified JavaScript. It will not look nearly as nice as this on any public program or any company you hack on, just because of stuff like Webpack, stuff like React, which is making JavaScript extremely hard to read. So unless you're using something like JS Weasel, this is going to be difficult for you to read. In this case though, the developers of this platform were nice to us, so we can very cleanly read the GraphQL endpoints. And you can see this is our get paste query that we were looking at before. So we already have that request saved, and if we go back, we find a few more. We have get paste public, so in this case I think this is the non-public endpoint. Perhaps we can do some client-side patch as well if we manage to inject public there. The local mutation, this is one that we've also seen before, so nothing specific here. And let's go down to something like import. We have not seen this one actually. So when we find a one that we haven't seen, you can copy paste it in and just simply, maybe we'll put it in this one just so you have the variables. This seems to be a mutation, so you can simply put it in here. And there'll be one issue with this, is that because this is like JSON formatted, you'll probably have to put it into some kind of formatter for you. So something like a line remover might work, or it'll make it JSON safe by just removing all the lines. We don't actually have to put the new line characters in, it's not necessary. But in JSON there cannot be spaces between the string, that's just not allowed. So we can stick it in here, you can see what happens here. Means like we need some like file name as well. Say put something like this down, content, and I see we have uploaded something. So we could test that functionality, see if there's some kind of file vulnerability there, like an SSRF or something like that. We could look at something like this. Let's go back to some of the quick upload. There's a file name as well here, import, upload. That seems to be most of the endpoints here. So we found 5 total queries, and now based on these we can probably chuck this into ChatGPT and just create actual enumeration and try and find like this. And this is, I think, the best way for finding GraphQL queries because we are actually leveraging the functionality on the website in order to find existing endpoints, and then we can expand on them and then enumerate them using something like automate later. There is something else that I have to mention, which is introspection. So GraphQL endpoints normally have something called introspection, which is the ability to send a request that basically tells you everything. It'll tell you all the queries, all the mutations, and all the object types created by the developers, basically leaking the whole API. That would be lovely if we had that. I mean, cracking GraphQL would be so easy. The issue is, and I need to set up this so you don't get disappointed in the future, is that most websites disable this. And really, they should disable this because this is quite powerful for an attacker to know every single endpoint, and every single endpoint has been deprecated. Every single endpoint, just in general, even used for testing by developers, will be there. But this is something that you should really disable on a website if you have a public GraphQL endpoint, and it will normally not be available to you as an attacker. That's why go for the introspection query. Definitely see if it's there. It probably won't be there, so you'll have to resort to something like this, attacking the JavaScript, finding functionality, and then testing it that way. That's the way that I would recommend to do it, and I think the best way to do it is that. And yeah, that's all I really wanted to cover for GraphQL. So the vulnerabilities you can find in them, what it actually is, and then how to enumerate it. The key kind of skills to approaching a GraphQL endpoint. So start off by basically getting it, finding it, and playing around with the syntax of it, seeing how the website actually implements it, start enumerating it, find a new endpoint, and then test the interesting endpoints for those web vulnerabilities, broken access control, etc. That's exactly how I would approach a GraphQL endpoint, and that's exactly how you can make money from it. That's the really thing that matters. I hope you enjoyed this video on approaching GraphQL endpoints. I remember when I was getting started and I saw one of these endpoints, I would always just get annoyed because it was so difficult to approach them. I just wanted the REST APIs, but hopefully with the help of this video, that's not going to be you, and you're actually going to be celebrating knowing that there's probably a lot of bounties hidden in that GraphQL endpoint. If you have any video suggestions, please leave them in the comments below. I'm a small channel. I'm talking to it's like probably 20 people at the moment. Probably most people have probably clicked off of that by this point. So if you're really watching this, I would appreciate your feedback in the comments. I will read all my comments, so if you leave one, I'll see you. I'll give it a like to make sure I've read it. And yeah, please leave your suggestions there. I'll probably make your video in like a week, so please leave it in the comments. And yeah, like and subscribe to see more content like this recommended to you in the future. And that's it for me. Thanks for watching, and happy hunting.